We now discuss an interesting theorem, binomial theorem. An expression containing two terms is a binomial. We are interested in knowing the expansion of a plus b raised to n. Initially, we say that n is a natural number, but then we obtain binomial theorem for any real index. Now tell me, what is a plus b raised to 1? It is a plus b. Now can I write a plus b as 1c0a plus 1c1b? Yes, I can, because 1c0 is 1. 1c1 is also 1. Okay. What is a plus b bracket square? It is a square plus 2ab plus b square. Now I write this as 2c0 a square. Basically, what is coefficient of a square? It is 1. Now index of binomial is 2, and that is why instead of writing 1, I am writing 2c0. Is 2c0 1? Yes, it is. Plus 2c1 ab plus 2c2 b square. Remember, I have to write the same thing. The only thing is I can write this in different form, which is allowed. Okay. Now, what is a plus b cube? A cube plus 3a square b plus 3ab square plus b cube. Okay. Now, can I say that this is 3c0 a cube plus 3c1 a square b plus 3c2 ab square plus 3c3 b cube? Yes, I can. I hope you have understood that C stands for combination. We have already done this topic. NCR, combinations of n things taken R at a time. So what is 3c1? Combinations of three things taken one at a time is 3. Similarly, 3c2 is 3 only. So I have written the same in different form. Now from this, in fact, this pattern suggests us the expansion of a plus b raised to n. Can you tell me what will be a plus b raised to n? It will be a plus b raised to n equal to nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 b square up to what? NCN b raised to n. This is called as binomial theorem and is to be proved using method of induction. Now let us discuss important features, interesting features of this binomial expansion, binomial theorem. Number 1, if the index is n, index of binomial is n, there are how many? N plus 1 terms in the expansion. I repeat, number of terms is one more. Number of terms is one more than the index of binomial. Secondly, index of a or the first term goes on decreasing by 1. At the same time, index of second term b in this case goes on increasing by 1. But sum of the indices of a and b is the same in each, which is nothing but n. See, n minus 1 plus 1, n minus 2 plus 2, n up to n. Okay. Then these are called as binomial coefficients, nc0, nc1, nc2, ncn. An interesting feature is binomial coefficients repeat in reverse order. Means what? Consider this. Here it is 1, 1. So first and last have the same binomial coefficient, which is 1. Second and second last are the same. Yes. And this is because of what? Because of this result. NCR is NC n minus R. For example, the first one is NC0. as per this result. This is NC n minus 0, that is n. Yes, the first one is NC0 and the last one is NCn. Yes, they are equal. Second one is NC1 and last but one is NCn minus 1. Same thing. Okay. So you have to remember that binomial coefficients repeat in reverse order. So if there are 7 terms, then you need not find 7 separately. Okay. It is sufficient to find 4. Now there are one or two more important observations, but we will discuss those observations later on. After this, I can say that what is a minus b raised to n? Basically, what is a minus b? It is a plus minus b. Okay. So same logic. What will be a plus minus b raised to n? It is nc0 a raised to n, rather nc0 a raised to n. Then nc1 a raised to n minus 1 into minus b. That is why minus sign in between, plus nc2 a raised to n minus 2 minus b bracket square is plus b square. Next will be cube of minus b, which is minus. So you will notice that expansion is the same. The only thing is terms are alternately positive and negative. And the last term is NCn minus b raised to n. Of course, sign depends on the value of n. Okay, so this is the expansion of a minus b raised to n. Is that clear? Yes. Now, just give the title Binomial Theorem. Now, give the title Binomial Theorem and just write this theorem. If a and b are real numbers and n is a natural number, then a plus b raised to n equal to what? nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b square up to ncn b raised to n. Now after this, write down remarks. First remark, number of terms is one more. Number of terms is always one more. Number of terms is always one more than the index of binomial. Than the index of binomial. Second, in each term, the sum of indices, SUM sum, the sum of indices of A and B, the sum of indices of A and B is always n, small n. Number 3, binomial coefficients repeat in reverse order. Binomial coefficients repeat in reverse order. Binomial coefficients repeat in the reverse order. Number 4, see on the screen, a minus b raised to n equal to, write down, Yes, right now. Actually, this should be, last term should be NCN minus B raised to N, right? Okay. After this, we will solve one sum from exercise 4.2. Expand root 3 plus root 2 raised to 4. So what will be the expansion? You have to write all the steps. This is 4C0. Do not write the value of root 3 raised to 4 directly. 4C0 root 3 raised to 4. Okay. Plus 4C1 root 3 cube into root 2. Okay. Right done. Plus 4C2 root 3 square into root 2 square plus 4C3 root 3 into root 2 cube, and what will be the last term? It will be 4C4 root 2 raised to 4. See, after few sums, we can drop this because 4C0 is always 1, or in general, NC0 is 1. NCN is also 1. Okay. After this step, what should be done? Find out these separately, 4C0 and so on, and then substitute. Okay, so 4C0 is 4C4, that is 1. 4C1 is 4C3, that is 4. What is 4C2? 6. Substitute. So you get 1 into 9 plus 4 into, what is root 3 cube? 3 root 3 into root 2 plus 6 into root 3 square 3, root 2 square 2 plus 4 root 3. What is root 2 cube? Root 2 2 into root 2 plus 1 into, what is root 2 raised to 4? 4. So 9 plus 12 root 6 plus 36 plus 8 root 6 plus 4, that is 49 plus 20 root 6. Second one is similar. You can do this after the lecture. So this is for homework. And what is the answer? 145 root 5 minus 229 root 2. This is expansion of what? I think second part is root 5 minus root 2 raised to 6. So we stop here.